Okay, next let's cover the Pacific and polar regions. And make sure you understand the concepts and terms like we usually do. We'll be talking about high islands and low islands and atolls and a few other things. Okay, so we've gone from the austral realm of Australia and New Zealand, and now we're kind of covering the rest of this stuff out in the Pacific Ocean. And we'll talk just a bit about the North and South Pole as well while we're here. They haven't been included in other chapters too much. But I want to step back and kind of think about some big picture geography things. So we talked about Malthusian scenarios where there's not enough resources to feed people. And we also think about like understanding geographic factors like relative location, for example. That relative location of a country has an impact on its resources and economy. And let me just kind of button this up by talking about two islands. One, we have Singapore, which we've discussed before. It has a population of over 5 million people and a GNI/PPP, kind of like average income of about $80,000. Actually, this is a little bit old, it's more now, but relatively high. In the US, it would be about 55. They have a higher standard of living than the United States. Now, Tonga, on the other hand, way out here, is about the size of Singapore over, collectively, but they have a much lower population, about 100,000 people, and about an average income that's about 1/10 of the US. And so Singapore is an island, Tonga is an island, but what makes them different? And part of it is Singapore's success is that it is its relative location right at the heart of the global economy. Now, part of Tonga's difficulty, on the other hand, is its relative location far away from the global economy. That this is one of the difficulty of island nations, is that the distance from other places make them much more disconnected from the global economy. It makes it difficult for them to be self-supporting. Many of them rely on the administration by other countries like New Zealand or the United States. It's very difficult for them to gain their independence and become economically self-sufficient. Let's talk for a moment about islands. Islands which are land surrounded by water kind of come in two flavors. There are continental islands, and basically they are part of a continent, but there's a little bit of, the continents don't end at the water's edge. The continents can extend underwater, and if you have a high spot, that will appear as an island, but it's not a true island like an oceanic island. Oceanic islands are made from volcanoes that come from deep in the ocean and build up land so high that they emerge out of the ocean. They are not connected to continents. They are created by a different process called a geologic hotspot. And let me kind of show what a hotspot is. So like the Hawaiian Islands, for example, they're volcanic. They're created by lava deep in the earth. And then there's a process where they get created and then they move, and then another one gets created and they move. So oceanic islands out in the Pacific are created through a different kind of geologic process. All right, so these are examples of continental islands. So Borneo, Sumatra, the Java, even. So these parts of Southeast Asia that are islands are physically part of the Asian continent. Likewise, Australia and Guinea are actually part of the same continent, but there's water separating the two as sea levels have risen during the ice ages. So Guinea here, which is part of it belongs to Indonesia, part of it that we're going to study called Papua New Guinea, is physically connected to Australia, but a lot of it's underneath the water. Oceanic, on the other hand, are created by geologic hotspots. So magma, like lava, right? But when it's inside the earth, we call it magma. It rises from deep within the earth, and it kind of builds up when it hits the surface. And then as it keeps going, um, we talked about plate tectonics before. So as this is happening, the plates are kind of moving in a single direction. So it's like a little island factory. The lava will come up, create an island, and that island will move away. Then it'll pop up, make a new island, and that island will move away. And so what that creates is a chain of islands, right? So if we look at the Hawaiian Islands, for example, the big island of Hawaii, that's the only one that has active volcanoes because it's still sitting on the hot spot. Other islands have moved away, like Maui and Kauai and Oahu. They were created and then moved off the hot spot. So like Kauai is like 5.1 million years old. Oahu's about 2.5 million years old. And the big island of Hawaii is about less than 1 million years old. So you're gonna go from the newest ones where the volcano is and to the oldest ones, which are kind of slowly drifting away because the movement of plates. All right, so you get a mantle plume. That's what these things are. The mantle plume doesn't move. The plate on top of the mantle plume does. Right, brings magma to the surface. It forms an island. The plate moves the island away. Next island is formed, kind of like a little island factory. So if you look at the Hawaiian Islands, we see kind of, this 5 or 6 or so islands, but there are more islands that have been eroded away underneath the water. This Hawaiian chain extends and even kind of takes a curve all the way up to near the area of Russia or Alaska up here. All right. Now, so you have newer islands and older islands. And another thing you have is the development of something called coral reefs. Coral reefs develop around a volcanic island. And coral reefs are not made of rock. They're made of skeletons of sea creatures, and they don't erode as easily as rock does. So Charles Darwin, when he was out studying evolution out in the ocean, he would see these different islands, and he came up with a theory about the evolution of islands. The idea is that, well, you start out with a volcanic island, right, with the volcanic activity, but then over time, coral reefs start to develop around the island, and then the process of erosion, rain and waves and so on, start to wear out the volcano itself. But the coral reefs are still there. And then eventually you get to a point where you have what's called an atoll, that the volcano part's all gone. It's kind of underwater still, but the top, the part is gone from being out of the water, but that coral reef that developed around it still remains. And these are different islands and different places that kind of give you an example of this process. All right, so the idea is that you have a volcanic island, you develop a fringing reef around it. Then over time, that island erodes away, and it moves, kind of shrinks in, and that fringing reef becomes a barrier reef. And then eventually the volcanic part wears out, and all you're left with is kind of an atoll. That's that coral reef that was there, it's kind of left over. Here's it in picture. You have a, you have a coral reef. You kind of see that around the island. But as the island erodes away, the coral reef can remain, and finally you can get to a point where it's only coral reef, and at that point it's called an atoll. All right, so these coral reefs, they're wave resistant, so meaning that they can survive longer than the volcanic rock. They're not geologic, they're biologic. They're created by the accumulation of skeletons of small sea creatures, and they don't develop everywhere. They need special conditions of sea temperature and chemistry. And so what these atolls are, they're a ring of coral reef that have survived. They grew up around a volcano, but as the volcano went away, the coral reef has survived. These are the places where you can have coral reefs, and you can see that includes much of the Pacific, including Hawaii and a number of other islands out into the Pacific. All right, so that gets us to this is probably the most important thing for this video. When it comes to the oceanic islands, we can kind of class them in two ways. We have high islands, which are the newer ones that still have the volcanic rock. If you recall from our Southeast Asian lecture, volcanic rock is very has a lot of nutrients and is very productive when it comes to agriculture. So on these high islands that still have volcanic rock and soils, agriculture is the primary activity because the soils are very fertile. For example, the Hawaiian Islands have very fertile soils for growing crops. And I should note, when we say economic activity, we mean like food producing activity. Tourism, of course, is probably going to be a bigger part of the economy, but as far as food producing, agriculture is more important on high islands, and the low islands are made of coral, right? So they're the atolls primarily. The nutritious volcanic materials all gone. The corals are not that productive for growing a lot of food. So on these, fishing is a primary activity. So understand that high islands are associated with agriculture and low islands are associated with fishing. Because the coral reefs are actually very productive fishing grounds. So fishing can be is the main food producing activity on these islands. Just some pictures. This is a high island. You can see the volcanic rock in the background. Here's another one. This is Bora Bora in Tahiti with a big volcanic rock. You can see a coral reef out in the distance. And this is a low island, kind of a remnant coral reef.